Okay, so here some questions are there. Draw the electron dot structure for ethane. Okay, electron dot structure for ethane. Draw the electron dot structure of any molecule which has a double bond. The atomic number of chlorine is 17. What is electronic configuration? 287. Explain the formation of chlorine molecule using a electron dot structure. That means chlorine molecule means we can take Cl2. Okay, chlorine molecule. So you answer to these questions. Now we will see the ionic and covalent bonds properties. We saw that covalent bonds are formed by sharing of electrons between atoms, and ionic bonds are formed when the valence shells of atoms gain or lose electrons. Okay, so here they are explaining about the covalent ionic bonds. So covalent bonds are formed by what? By sharing of electrons between atoms, and ionic bonds are formed by what? When the valence shells of atoms gain or lose the electrons. So the compounds having ionic bonds are known as ionic because they lose and gain the electrons. After gaining the electron, they are becoming ion. Chlorine, when it is getting the electron, it is becoming ion or anion and receiving the charge, negative charge. Yes, and then so like that only sodium chloride when we take so sodium is losing one electron and getting the positive charge, becoming sodium ion. Chlorine is gaining one electron and becoming negative charge and anion. So known as ionic or electrovalent compounds. When they gain and lose the electron, they are forming a electrovalent bond or electrostatic bond, which is very strong bond. And the compounds, than the covalent bonds, ionic bonds are very strong. And the compound that have a covalent bonds are known as a covalent compounds. So if it has the sharing and gaining electrons means it has the ionic bond. If they are sharing the electrons means they have a covalent bond and they are called as a covalent compounds. Covalent compounds examples are what? H2O. So by looking at this we can say if the hydrogen is non-metal, oxygen is non-metal. So covalent bond is taken between the two non-metals. Here sodium is metal, chlorine is non-metal. Ionic bond is taken between the one metal and one non-metal. By looking at these names we can say which has the ionic bond, which has the covalent bond. If you take the periodic table, easily you can find out which is metal and which is non-metal. All the color in brown is the metal and other side is the non-metals are present. Now in the periodic table, left side metals are present, right side non-metals are present. Okay, so here that is the one. So now we look at the properties of the both the bonds. First, the properties of the ionic bond. So usually ionic compounds are soluble in water. Ionic compounds are what? Soluble in water. Sodium chloride is the common salt. Salt. Salt is a salt soluble in water? Yes. So ionic compounds have high melting and boiling points because the opposite charged ions in them are held together by strong electrostatic forces of attraction. So if there is a positive and negative charge, opposite charges has the more attraction, so that they have the more strong bond. Okay, plus and minus opposite charges. That is why battery also when we attach the battery, this side plus and this side minus. Which side we will be keeping the charges? This side plus and battery is here plus minus. And one more battery what we keep? Plus minus. So opposite charges has the more attraction towards each other, so electricity will flow. So like that only in the ionic bonds, because of the opposite charges they have the strong bond. That is why sodium metal. Okay, for example another one you say iron, aluminium, all those are the metals. They need high boiling point to be melting. Okay, iron rod to burn that one, how much melting? High melting, high boiling point means high temperature we need to burn the metal. Okay, so this is the one. So that ionic bonds need high melting and boiling points. Okay, so since they are more attracted, so they need more energy to separate. For example, two friends are there, they are very thick friends, strong friends. To separate them we need so many days and more energy we need, because they are very strong friends na. So like that only. So ionic compounds ionize when dissolved in water or on melting, therefore can conduct electricity. Since ionic compounds are soluble in water, so that they can conduct electricity, ionic compound, because they have the positive and negative charges, so that they can conduct the electricity. Okay, so that is the one. Now covalent compounds properties we see. Covalent compounds are not soluble in the water, and their melting and boiling points are low as compared to ionic compounds. Covalent compounds do not conduct electricity because they do not form ions, because covalent compounds don't have the charges na. Yes, so we will now examine whether different ionic and covalent compounds conduct electricity or not. So we will see now whether ionic and covalent compounds can conduct the electricity or not. So we will see now. So here we will take four beakers, label them A, B, C and D. Take 100 to 150 milliliter of water in each beaker and prepare separate solutions. Okay, so we are taking in four beakers water. So in A beaker we are keeping the common salt NaCl, and in beaker B calcium chloride CaCl. Na is metal, Cl is non-metal. Calcium is metal, Cl is non-metal. So it forms what? Ionic bond or covalent bond? It is forming ionic bond. Okay, so next one we will see. Beaker C sugar, beaker D glucose. Okay, sugar and glucose are the covalent bonds on, because carbon only is there in that. Okay, so first insert two graphite rods in beaker. Graphite rod, it is the which conduct the electricity. Graphite is the non-metal, but it can conduct the electricity. The graphite rods act as electrodes. Connect these rods to a bulb and a 9-volt battery as shown in the figure to complete the circuit. Take care that two rods do not touch each other or come in contact. Do the bulb light up? Okay, so next one. Beaker A, what we are taking? Sodium chloride na. So in the sodium chloride only they are asking us to keep the rods, graphite rods. Sodium chloride forms which bond? Ionic bond. So repeat the experiment with other three beakers. Note the observations. Why did the bulb light up in case of beaker A and case of beaker B? So beaker A and beaker B, we are taking calcium chloride is the metal and non-metal ionic bond. Both are ionic compounds. And here this both are what? Covalent compounds. Okay, covalent compounds. Now we are trying with this one. Now you see bulb is glowing. This solution is what? Sodium chloride, graphite rod, and here battery is there, bulb is there. Electricity is conducted, so that light is burning. Okay, so now here in beaker C, beaker D, electricity will not flow because it is the covalent compound, because they don't have the ions, positive and negative charges they don't have. Why they don't have? Because they share the electrons to fill the octet. Ionic bond means they gain or lose the electrons to fill the octet. So you must have understood now that electricity is conducted by salt and calcium chloride because of electrovalent bond, that means ionic bond, but not in glucose and sugar because they have the covalent bonds. So okay, so ion, cation means what? Positive charge, anion means negative charge. Ion means after losing and gaining electron they form the ions. Ionic bond means sharing and losing the electrons form the ionic bond. Gaining and losing. Covalent bond, sharing of electrons. Okay, valency, ionic compound. Valency means what? For example, carbon atomic number is what? 6. So 2, 4 electronic configuration. So it needs how many electrons to fill the octet? 4 more. So see, valency is 4. Valence is 4. Valence electrons means C. Valence electrons means 4. How many it is getting to fill the octet? It is called as a valency. Okay, with this we have finished the lesson. Dear students, read once more, watch the videos again and again, underline the important points, and this one you fill all these blanks and choose the correct option. Okay, so I will send some homework in the Google Classroom. Thank you, students.